Hello everyone and welcome back. Thanks for joining me again in this mini video series about the role of cloud solution architect. In this video, we will move on to step 4 in the cloud architectural methodology solution architectural design. But before we begin, let's take a moment to review what we covered in the previous video. In the previous video, we explored the step 3 of the cloud solution architectural methodology, which I use proof of concept, to the Zoran Trend retail case study. We demonstrated how the cloud solution architect designs and execute a small scale of prototype to validate key components of the cloud strategy. We deployed a simple website using Azure App Service, migrated 100 gigabyte subset of the data to Azure SQL database, and tested AI-driven product recommendation using Azure Machine Learning, all with an Azure Sandbox environment. Now let's start with this video, Cloud Architectural Design. Solution architecture design is the phase where a cloud solution architect transforms business and technical requirements from the strategy and planning phase into a detailed, actionable blueprint for a cloud-based solution. It outlines the system's structure, components, and interaction, ensuring alignment with objectives such as scalability, security, and cost efficiency. This phase designs a tailored cloud environment blueprint, ensuring components integrate seamlessly for performance, security, and future growth. Although focused on Azure, similar principles apply to other cloud platforms such as AWS and GCP. Within the cloud solutions architect methodology, solution architecture design is a critical phase, transforming a conceptual framework into a concrete technical blueprint. Solution architecture design entails developing a detailed plan that defines the cloud solution structure, integrating cloud services, components, and technologies to meet business requirements, technical specifications, and compliance standards. It designs the interaction among systems, application, and data in the cloud environment. A best practice is to first create an architectural proposal, a comprehensive document or presentation that outlines the proposed cloud infrastructure design and implementation to align with business and technical requirements. The architectural proposal is typically created and presented before finalizing the full architectural design. This approach ensures alignment with stakeholder expectation and business goals, enabling a more focused and effective detailed design phase. The process is iterative, allowing the proposal to be revisited if significant changes or new insights emerge. Present the proposal. Convene a meeting with key stakeholders to present the architectural proposal, using visuals like diagrams to clarify complex concepts. Be prepared to address questions on cost, security, compliance, and performance. Collect feedback, gather stakeholder feedback during this session to inform potential adjustments to the proposed architecture. Now turn back on full architecture design. We now developed the architecture design using a real-world scenario for Zoran Trend Retail. First, a brief recap. Zoran Trend Retail, an online retailer generating $20 million annually from clothing and related products, employs 150 staff and serves 500,000 customers, including European clients. Their website and mobile app manage 10,000 daily visitors, peaking at 50,000 during events like Black Friday. Their current infrastructure, relying on aging on-premises servers in Chicago and Denver, comprises 10 physical racks running 20 virtual machines, each with 16 vCPUs and 64 gigabytes of RAM. Performance challenges include slow app response times, averaging 500 milliseconds, spiking to 2 seconds during peak usage, 200,000 actions per hour peaks, and an unstable 1 terabyte database storing 10 million sales records and 500,000 customer profiles, which has crashed twice for 4 hours each, resulting in $250,000 in lost sales. Annual operating costs total $300,000, $25,000 a month, including $80,000 for power, $120,000 for software licenses, and $100,000 for impending hardware replacements. Objectives include achieving 99.9% uptime to prevent crashes, reducing up latency below 300 milliseconds, delivering AI-driven product recommendation in under 200 milliseconds, scaling to 1 million actions per hour, and providing 5 personalized recommendations per user with 80% relevance. These goals must be met within 3 months, with a $50,000 budget by March 2025 and $100,000 total by May 2025, reducing annual costs to $180,000, saving $15,000 monthly. Solution: develop an Azure-based system to replace Zoran Trend Retail's outdated infrastructure, achieving 99.9% uptime using geo-replicated SQL database and Cosmos DB with multi-availability zone app services, reducing app latency below 300 milliseconds, and AI inference below 200 milliseconds via 10 AppService instances and Azure functions, scaling to 1 million requests per hour with sharded Cosmos DB, 10,000 IOPS, and delivering 5 recommendations per user with 80% relevance using Databricks and Azure Machine Learning, all for $180,000 annually. Execute migration in 2 phases: app and database by March 2025, and AI integration and replatforming by May 2025. For the architectural design, we need to create several very serious documents. I will start in order and try to show you how some of these documents should look like and what they should contain. Part 1. Requirements mapping document. Define technical requirements with actionable solutions. In February 2025, we convene stakeholders, CEO, CFO, CTO, compliance officer, and marketing to present a high-level architectural proposal for Zoran Trend Retail. This blueprint envisions a reliable, fast-loading digital store with personalized AI-driven product recommendations, all secured cost-effectively. The proposal outlines a multi-tier Azure architecture utilizing app services for the website, SQL database, and Cosmos DB for data management, and Azure Machine Learning for AI interconnected via a virtual network. The requirements mapping document translates Zoran Trend Retail's objectives into technical specifications. To ensure 99.9% uptime and avoid $250,000 outages, we propose Azure SQL Database, 1 terabyte, 8 vCPUs, geo-replicated to WestUS, and Cosmos DB, 500,000 customer profiles, 4,000 request units per second. For latency below 300 milliseconds and 1 million requests per hour, we deploy 10 AppService instances in East US, load balanced by Azure Application Gateway for 700,000 dynamic requests, and Azure CDN for 200,000 static image requests. 10 gigabytes product photos cached in EU West and US East. For AI recommendation under 200 milliseconds with 80% relevance, Azure Functions and Machine Learning collaborate with Databricks for daily model updates. Microsoft Defender for Cloud with Defender for SQL and Cosmos DB plans, and Microsoft Entra ID ensure GDPR compliance, securing data for 500,000 customers. This proposal secures stakeholder approval, paving the way for detailed design. Now Part 2, Architecture Diagram Document. The Architecture Diagram Document maps Zoran Trend Retail's new online store as a multi-tier system in East US, featuring 10 app service instances across availability zones for 99.9% uptime, managing 1 million requests per hour. Azure Application Gateway, functioning as a traffic manager, routes 700,000 dynamic requests, e.g. orders, with its web application firewall to block cyber threats. Azure CDN caches 200,000 static requests, e.g. product images, from blob storage in EU West and US East, achieving latency below 300 milliseconds, as validated at 280 milliseconds in the proof of concept. Azure SQL Database and Cosmos DB, replicated to West US, store 1 terabyte of sales data and 500,000 customer profiles, preventing crashes. Azure Functions, machine learning, and Databricks provide AA recommendations in under 200 milliseconds. A virtual network secures all components, with ExpressRoute facilitating a 1 terabyte on-premises migration. Zoran Trend Retail Data Flow Diagram. Now I'm excited to walk you through the data flow diagram for Zoran Trend Retail's Azure Cloud Architecture, specifically focusing on the data movement, as outlined in part 3 of our project documentation. This diagram illustrates how our system handles 1 million requests per hour for our 500,000 customers, ensuring we meet our goals of 99.9% uptime, application latency under 300 milliseconds, AI-driven recommendation in under 200 milliseconds, and GDPR compliance, all while optimizing costs. Let's dive into the flow, starting with our users. Step 1. Users and the initial requests. On the left side of the diagram we have our external entity, labeled users 50K, representing Zoran Trend Retail's 500,000 customers. On a typical day, we see 10,000 daily visitors, but this can surge to 50,000 during peak events like Black Friday. These users generate 1 million requests per hour, which are split into static and dynamic requests. Step 2. Static requests via Azure CDN first. Let's look at the static requests, which account for 20% of the total, or 200,000 requests per hour. These requests are routed to the component labeled 1.0 process static requests, represented by Azure CDN. Azure CDN fetches 10 gigabytes of product images from Azure Blob Storage, shown here as D1 Azure Blob Storage, which is geo-replicated across EU West and US East regions for low latency and GDPR compliance through transparent data encryption, TID. The flow is labeled fetch static content, and Azure CDN delivers these static assets back to users in 280 milliseconds, as validated in our proof of concept, well within our target of under 300 milliseconds. This return flow is labeled static content delivery, 280 milliseconds latency. Step 3. Dynamic requests via application gateway and app services. Now, let's move to the dynamic requests, which make up 70% of the total, or 700,000 requests per hour. These requests flow from users to the application gateway, which routes them to app services, labeled process dynamic requests. The application gateway ensures secure and efficient routing, as indicated by the arrow labeled route dynamic requests. App services processes these 700,000 requests per hour, contributing to our total capacity of 1 million requests per hour. From here, the dynamic requests branch into two subflows: database queries and AI inference requests. Step 4. Database queries with Azure SQL and Cosmos DB. First, let's look at the database queries, which account for 20% of the total requests, or 200,000 queries per hour. This flow is labeled database queries, 20% of 1 million requests per hour. and goes to a process labeled Query Databases. This process interacts with two data stores, Azure SQL Database and Cosmos DB. The Azure SQL Database, labeled Azure SQL Database, stores 1 terabyte of sales data, including 10 million order records, and is geo-replicated to US West to ensure 99.9% uptime. The flow to SQL is labeled Fetch Orders. Next, Cosmos DB, labeled Azure Cosmos DB, stores 500,000 customer profiles and catalog data, with a throughput of 4,000 request units per second, geo-replicated across US West and EU West for GDPR compliance. This flow is labeled Fetch Profiles/Catalog. Together, these databases handle the 200,000 queries per hour efficiently, supporting our application's performance needs. Step 5. AI recommendation with Azure Functions, AML, and Databricks. Next, let's explore the AI-driven recommendations, which make up 10% of the total requests, or 100,000 inferences per hour. This flow starts from App Services and is labeled AI Inference Request, 10% of 1 million requests per hour. It goes to Azure Functions, which acts as a trigger for our AI processing. Functions then connect to Azure Machine Learning, labeled Generate AI Recommendations, with the flow labeled Trigger AI Inference. AML processes these 100,000 inference per hour in under 200 milliseconds, achieving 80% relevance, as noted here. To generate this recommendation, AML fetches customer profile data from Cosmos DB, with the flow labeled Fetch Profile Data for AI. Additionally, AML relies on daily model updates from Azure Databricks, labeled Databricks Processor Data, which stores 1 terabyte of processor data. This flow is labeled Fetch Processor Data for AI model, ensuring our AI model maintains 80% relevance. Once the recommendations are generated, they flow back to App Services, as indicated by the arrow labeled AI Recommendations. Step 6. Return flow to users. Finally, App Services consolidates the responses from the database queries and AI recommendations, sending them back to users. This return flow is labeled the Dynamic Response, completing the cycle for dynamic requests. This ensures our users receive timely and relevant responses, with application latency well under our 300 millisecond target. Conclusion and impact. To summarize, this data flow diagram illustrates how Zoran Trend Retail's Azure system efficiently handles 1 million requests per hour. Static requests are served in 280 milliseconds via Azure CDN. Dynamic requests are processed securely through Application Gateway and App Services. Database queries are handled by Azure SQL and Cosmos DB, and AI recommendations are delivered in under 200 milliseconds, with 80% relevance, using functions, AML, and Databricks. This architecture supports our goals of 99.9% uptime, low latency, and GDPR compliance, all while reducing costs from $300,000 to $180,000 annually, with further optimization to $175,000 as we progress. This system, implemented by May 2025, positions Zoran Trend Retail for scalable growth, with plans to handle 1.2 million requests per hour by the end of this year. Now a part 4, Network Design Document and Landing Zone. The Network Design Document ensures secure connectivity across the architecture. We established an Azure Landing Zone using a hub-and-spoke model, with the hub's virtual network 10.0.0.0/16 in East US hosting Entra ID and Azure Policy for Governance. Spokes for applications, database, and AI, each with subnets, use VNet peering for communication under 5 milliseconds. ExpressRoute's 1 gigabit circuit transfers 1 terabyte in under 3 hours, while Microsoft Defender for Cloud's Cloud Security Posture Management CSPM enforces GDPR-compliant configuration, restricting resources to East US, West US, and North Europe. This creates a secure, efficient data network for Zoran Trend Retail. Solution: deploy the landing zone in Phase 1, February 15 to March 31st, 2025, with a hub in East US for Entra ID, policy, and monitor, ensuring 99.9% uptime. Configure spokes for app services, 10 instances, geo-replicated SQL Cosmos, and Databricks Azure Machine Learning. Connect via ExpressRoute 1 gigabit per second for 1 terabyte synchronization. Refine in Phase 2, April 1st to May 31st, 2025, with AI policies, decommissioning on-premises system by May 31st. Next is Part 5, Security Design Document. This ensures Zoran Trend Retail's 500,000 customers and 10 million sales records are protected from cyber threats, with robust authentication and compliance with regulations like GDPR. The security design document establishes a fortified digital environment, deploying a virtual network with private endpoints for app services, Azure SQL database, and Cosmos DB to keep data within Azure's secure backbone, shielded from the public internet. Azure Application Gateway's web application firewall protects 700,000 dynamic requests per hour, blocking threats like SQL injection and DDoS attacks. Azure CDN secures 200,000 static requests, such as the 10 gigabytes of product images, using HTTPS encryption and geofiltering to limit access to US and EU regions, ensuring GDPR compliance. Microsoft Defender for Cloud, with Defender plans for App Service SQL and Cosmos DB, audits GDPR compliance, verifies transparent data encryption on blob storage in EU West, and monitors threats via the Security Center dashboard. Microsoft Entra ID manages single sign-on for 150 employees and 500,000 customers with role-based access, such as contributor roles for IT staff. Azure Policy enforces encryption and tagging to comply with GDPR, using TLS 1.3 and AES 256, with Defender for Cloud flagging unencrypted connections. This safeguards data, prevents breaches, and ensures compliance for European customers. Solution: implement Entra ID for single sign-on. Deploy a virtual network with subnets and network security groups. Secure SQL Cosmos with private endpoints, encrypt with TLS 1.3 AES 256. Enable web application firewall and DDoS protection on gateway, and use Monitor for threat logging. Go to Part 7. Migration Strategy Document. This plans Zoran Trend Retail's transition from legacy systems to Azure in 2 phases for a rapid, cost-effective deployment by May 2025. Description: Phase 1, February 18th to April 7th, 2025. Migrates the application to App Services and 1 terabyte database to SQL database and Cosmos DB, using ExpressRoute 1 gigabit per second for a transfer under 3 hours. Azure Application Gateway handles 70% of dynamic requests, 700,000 per hour, and Azure CDN caches 20% of static asset requests, 200,000 per hour, 10 gigabytes product images in EU West and US East. Phase 2, April to May 31st, 2025, replatforms to .NET 6, integrates AE via functions, Azure Machine Learning and Databricks, and decommissions on-premises systems. This leverages ExpressRoute for efficient 1 terabyte transfer, app services for scalable compute, 1 million requests per hour, and SQL database and Cosmos DB for reliable storage.
99.9% uptime, with AI delivering recommendations under 200 milliseconds at 80% relevance. Virtual Network, Defender for Cloud, and Entra ID ensure GDPR compliance, while monitor and policy track progress. Incorporating POC lessons, like schema validation, to meet performance and cost goals, $180,000 per year. Part 9. Disaster Recovery Plan Document. This guarantees Zoran Trend Retail's website remains operational with less than 9 hours of annual downtime, with rapid recovery to prevent $250,000 losses from outages. What is a disaster recovery plan? A disaster recovery plan (DRP) is a strategic guide, akin to an emergency playbook, designed to restore critical systems and data swiftly after disruptions, such as data center failures, cyber attacks, or accidental deletions. For Zoran Trend Retail, the DRP prevents crises like the Black Friday outage that cost $250,000 and affected 50,000 customers. Why it matters for Zoran Trend Retail? The DRP is essential for the cloud migration, ensuring operational continuity, data protection, customer trust, and cost savings. It maintains 99.9% uptime, restoring services within 30 minutes, limits data loss to 15 minutes for 10 million sales records and 500,000 customer profiles, ensures GDPR compliance, and prevents significant financial losses. Solution: configure geo-redundancy for SQL database and Cosmos DB to WestUS 1 terabyte synchronization. Deploy app services across East US availability zones for 30-second failover, and schedule daily 1 terabyte blob storage backups to ensure 99.9% uptime and mitigate $250,000 outage risks. Part 10. Monitoring and Logging Plan. This ensures Zoran Trend Retail system remains fast, under 300 milliseconds, reliable, 99.9% uptime, and secure, preventing $50,000 losses from slowdowns and $250,000 from outages. Description: the monitoring and logging plan serves as the backbone of Zoran Trend Retail's cloud system, maintaining constant oversight of website performance, data security, and system health. Envisioned as a 24/7 monitoring hub, it proactively identifies issues to ensure seamless operation, drawing lessons from past incidents like the Black Friday outage. Why monitoring and logging matter? This plan is critical to address Zoran Trend Retail's challenges, such as the $250,000 outage affecting 50,000 visitors. It supports a fast, reliable, and secure system while achieving $120,000 annual savings. Continuous monitoring detects issues early, maintains cost efficiency, and ensures GDPR compliance. Now, Part 11. AI Integration Plan. This equips Zoran Trend Retail with an intelligent system to enhance purchasing by reducing the current 60% cart abandonment rate. The AI Integration Plan is a pivotal component of Zoran Trend Retail's cloud migration, blending innovation with enhanced customer experience. It leverages artificial intelligence to provide personalized product recommendations, streamlining and enriching the shopping process. By analyzing customer behavior and sales data, the AI system tailors suggestions to individual preferences, acting as a virtual personal shopping assistant. Beyond improving the shopping experience, it drives significant business outcomes. With a 60% cart abandonment rate, Zoran Trend Retail loses potential revenue. The AI system targets a 10% reduction, potentially adding $2 million in annual revenue. Built on Microsoft Azure's robust AI tools, it ensures speed, scalability, and security. Now, testing and validation plan. Objective is verify system performance before launch. The testing and validation plan is the final pre-launch checkpoint, confirming system readiness for real customers, data, and challenges. Envisioned as a dress rehearsal, it rigorously tests all components, from website load times to AI recommendation accuracy, ensuring no repeat of past issues like the Black Friday outage, leaving nothing to chance. Deployment timeline. Objective is achieve system launch within 3 months. The deployment timeline serves as the strategic roadmap for Zoran Trend Retail's cloud migration, meticulously coordinating every phase to ensure a seamless launch on May 31st, 2025. Beyond a mere schedule, it orchestrates data migration, staff training, and system integration with precision, addressing past challenges like the Black Friday outage to deliver a successful rollout. Why the timeline matters? The timeline is vital to resolve Zoran Trend Retail's issues such as the $250,000 outage affecting 50,000 visitors. It ensures a faster, more reliable, and cost-efficient system. By meeting critical deadlines for data migration, security implementation, AI integration, and team training within 4 months, preventing costly delays and ensuring a smooth launch.
That was all for this video. See you in next one, implementation and migration.